So here is the video on how to analyze an AC circuit by applying Thevenin's theorem. So let's say you have this system and you need to find out what is the current flow on this load impedance. So normally we label this terminal as A, terminal A, B. So basically the main objective of Thevenin's theorem is to transform the actual circuit, this actual circuit, into Thevenin's equivalent circuit, where you need to find out what is the VTH, ZTH. Then later on you can calculate what is I naught that flow through this load. So this is what you have to do for your lab. Okay, first thing you need to calculate what is ZTH and VTH. You can do so by using Multisim. So first you need to construct this circuit on Multisim. So you can get your current source from here. Look for AC current. So just select this, press OK, and place here. Okay, to key in the value, double click, and let's say the frequency is 50 Hertz. And then since we have the value of current is 12, angle 90. So the angle is 90. So this value should be the RMS value. Normally the question given in RMS value, so you can just enter here as 12. Okay, and for peak value you need to calculate the peak value using the RMS. So V peak is equal to V RMS multiplied with square root 2. So V RMS is 2 multiplied square root 2. So it should be 16.97. Okay. So for resistor, capacitor and inductor, you can get from here. You can just change the value to 4. Okay, for capacitor, the value is given in ohms, so you need to convert it into farad by using this formula. Xc is equal to 1 over J omega C. So from this equation you can get the value of C, where F is equal to 50. So you can simply measure the current flow in this load using multimeter. Okay, connect this to here, and then you can test it. Oh, so you need to have ground. So you have to change this to AC current and this to ampere. So the value should be 9.8. However, we need to measure it in with the angle. And you can simply get the answer by measuring current flow to this load, but the question asks you to perform Thevenin's theorem to solve this circuit. So you need to determine what is your ZTH and what is your VTH. So to measure your ZTH, you need to remove your source. If you have current source, you need to open this circuit, and if you have voltage, you have to short circuit it. So just copy this and paste to here. And for your load impedance that connect to terminal A and B, you have to remove it first. So then you need to measure your impedance from here. So you can get your impedance meter from here and just connect to this. Okay. Oops. So this you have to change to 50 Hertz since your frequency is 50. And then click run. Oh, okay. So you need to measure your ZTH, you need to remove your ground, otherwise your answer is not correct. Okay, so the value should be 3.33, and your for resistance, and your impedance is 3.33 as well. So next step is to measure your VTH across this inductor load. So you can just copy this and paste down here. Oh, okay. Okay, and then you can connect to multimeter. Okay. And click run. So this is actually the magnitude value. So you need to find out what is the angle, phase angle. So to determine the both real to determine the both magnitude and angles, you need to perform a single frequency AC analysis. So first step is you need to find out what is your net value. So click on properties. So you have to memorize this. Net name is 15. Then click on simulate analysis and single frequency AC analysis. So you have to change this frequency to 50, and then you need to determine in magnitude and phase, and then click on output. So you have to find out what is your V15. 15 is the net name. Click add and then simulate. So this is your value for VDH. Okay, so you have to write down this value so that you can construct your equivalent circuit using your VTH value, ZTH value, and Z load. Okay, so next step is to draw your equivalent circuit. So you can find where you need to have your current source, voltage source. So AC voltage, so this one should be 44.72, and then angle is 116. So this part should be value that you get from the single frequency AC analysis. Yeah, this value. Okay, so and again you have to change your RMS value into peak value. So multiply 44.72 with square root 2. So you will get 63.27. And this you have to change to 50 Hertz. Okay. So since your ZTH, the value of X is positive, so means that you are connecting with inductor. If negative, you should connect with capacitor. So you need to determine what is your value of L by using 2 pi f. No, it should be XL over 2 pi f. So 3.33 divided with 2 pi 50. So you will get 10.61 millihenry. And your RTH should be 3.333. So connect with your resistor, 3.333, and inductor should be 10.61. So this is your Z load. So I'm going to copy it. And don't forget your ground. So this is your equivalent circuit, where this is your VTH and this is your ZTH. So you need to calculate what is the load flow to this. So since this is the series circuit, so the current flow through the circuit is same. So to determine what is the value of magnitude and angle for the current, so you need to perform the single frequency AC analysis again. So from here, just leave it frequency 50, magnitude and phase, and then the output should be remove this. So you can simply take any value, maybe current for R9. It should be same. Okay, current for R9. Maybe you can add another one, current for C5, and then click simulate. Yeah, okay, so this is the answer. Okay, so this is how to analyze AC circuit using Thevenin's theorem in Multisim.